For our second topic, we're going to be looking at histograms. So these are very, very similar to bar graphs, and we'll see why in a second. So at the start here, let's circle the sentences that describe a bar graph. So number one, it has bars of the same width that touch each other. Well, they're the same width in a bar graph, but they do not touch each other. So we cannot circle that one. And number two, let's see, the length of each bar shows the number in each category. That's true. So we could circle that one. And the bars can be horizontal or vertical. That is also true. We saw that in the first topic that we did. So now let's look at histograms. If we're thinking about the difference between bar graphs and histograms, in bar graphs, each column represents a group defined by a certain category value. So for instance, that would be like those movies we did where it was comedy, romance, action, and so on. Whereas histograms, each column is defined by a continuous variable. So for instance, ages are continuous or years are continuous. Now this will make more sense once we look at these examples. Now in histograms, it is important to note that the bars do touch each other. So this one point up here that we said bar graphs do not do, histograms do. Let's look at this example with Matt working at the post office. This frequency table shows the masses of parcels he weighed for postage last month. What does this histogram tell you about the masses? So I just want to show you here. This is what I mean by continuous variables. Instead of just having one number, for instance, mass of 500, mass of 501 grams, mass of 502 grams, instead of doing each individual mass like that, they grouped the masses into ranges, 500 to 1,000, 1,000 to 1,500, and so on. And you'll notice over here that all the bars are touching each other, as opposed to the bar graphs where they were not touching each other. So let's look at number one. Describe the data in this histogram. The horizontal axis shows masses of parcels. The width of each interval represents, well, how many grams are there in each interval? 500 to 1,000, that would be 500 grams. And you'll notice each interval goes up by 500s. It is important to keep that consistent. Now the vertical axis here, that's this one here, it's asking us what it shows. Now it shows the number of parcels, but there's actually a special word for that in histograms, and that is frequency. Frequency means the number of times an outcome occurs. So that's just another way to say the number of parcels. For number two, we need to circle the correct word or phrase to complete each sentence. So for each of the first three intervals, the number of parcels is about the same or a wide range. For the first three intervals, that would be these three up here. Does it say about the same or does it move a lot? Looks like it stays about the same to me, so I'm going to circle that one. For each of the last three intervals, the number of parcels is more or less than 250. Well, 250, that would be right here. So let's follow that onto the graph. And it looks like all three of the last intervals here are less than 250. In number three, it says, can Matt tell the exact mass of any parcel from the histogram? And the answer is no, because all of the masses are in ranges, and they range in increments of 500. So the masses of individual parcels can be anywhere in between this range. It could be 550, 592, 748. Same goes for these intervals over here. We don't know the exact weight of any of the parcels. We just know the frequency of a range of weights. What does the histogram tell Matt about mass? There are about blank parcels in each blank gram interval. Well, we know our intervals are 500 grams, but approximately how many parcels are there in each 500 grams. So this is just an estimate. Let's look at where all of these intervals are hovering. So all of them are within this range right here, because we have some right here, we have some in the middle here. These ones dip a little bit lower, but for the most part, they stay all in between 200 and 300. So a good estimate of how many parcels there are in each of these intervals is about 250. We'll just say the number in between 200 and 300. The least possible mass is just over, let's see. Well, if we're looking at the mass scale over here on our horizontal axis, what is the least mass that we have on our graph? That would be 500. So the least possible mass is just over 500 grams. Again, let's go look at our graph to see the greatest possible mass. So the greatest mass that we have on our graph is 3,500. Let's put in here 3,500 grams. And now let's move on to the next page. So in this example, this data on the side over here shows the number of acres on 32 sugar beet farms near Tabor. Quinn's family wants to grow sugar beets on their farm near Tabor. I'm not sure if I'm saying that word correctly. How can Quinn's family use this data to help them decide how many acres they should use for sugar beets? So to start the solution, we need to start by organizing the data into intervals to create a frequency table. So let's choose the number and width of the intervals. That's the tricky part, because all of this information has to fit on our graph. And it wouldn't make sense to count up by 1, 2, 3, 4, because we're never going to get to the highest number on this table, which is 836. So we need to decide what our intervals are going to be. So let's determine the range. Now remember, the range is the difference between the biggest value and the smallest value. So if we're looking at our little chart over here, what is the smallest value we see? Well, I think it is 59. And the biggest one is 836, but they gave that to us already. So we're going to do 836 minus 59, and that will equal 777. Now we need to choose an appropriate number of intervals. So let's say we wanted to use 100 for the width of each interval. And remember, in the last example we did up here, they used 500 for the width of each interval. But let's say we wanted to use 100. We would divide 777 by 100 and round up to get blank amount of intervals. So 777 divided by 100 gives us 7.77. And if we round up, that would give us 8 whole intervals. So let's start with the first interval. We need to choose a value that is lower than the minimum number. And remember, the minimum number is 59. That's the smallest number on our chart there. So we need to start our first interval with a number just below 59. So they give us that number here, 50. That's the one they chose. And we decided that we were going to do intervals of 100. So that's why they did 50 to 150, because that is a 100 interval. So let's complete the rest of this chart here. The next interval would be from 150 to 250. The next one would be 250 to 350, and so on. So I'm going to work all the way to the end there. So now I filled out all of our intervals in this row of our chart here. Next, we need to look at the frequency. Remember, the frequency is the amount of times something occurs. So they got 18 for this frequency, between 50 and 150. And what that means is that if we're looking at our little chart up here, there should be 18 numbers that fall between 50 and 150. So let's see if we can find those. I'm going to circle all the numbers that fall between 50 and 150. Okay, so I circled all of the numbers that fall between 50 and 150 because that's the interval we're looking at right now. And they told us that there should be 18 of them between those two numbers. And if you look up at our little chart here, I did find 18 numbers to circle there that land between 50 and 150. So now we're going to do the exact same thing except for the next interval, 150 to 250. So I'm going to circle all the numbers that fall between 150 and 250. Okay, so in red, I circled all the numbers that fall between 150 and 250. So if we count them, we have 1, 2, 3, 4, 5, 6. So the frequency of this interval is 6. We're going to do the same thing for the next interval, 250 to 350. So I'm going to circle them in green here. We have 350 here, and this 290 here falls between those two. So our frequency for this one is only 2. Next, let's look at 350 to 450. So I see this one here, and this one here. So that frequency would be 3. 450 to 550. I see this one and this one. So the frequency there would also be 2, just like that other one in green. 550 to 650. Well, the only number we have left is this one down here, and that doesn't fall between 550 and 650. So that frequency is actually 0. 650 and 750, that frequency would also be 0. And there we have it, 1. That would be this one right there. So now we have to take all this data that we just put in this little chart and we're going to actually graph it. So they were nice to us and they gave us the title of the graph as well as the frequency label on the side there. So let's label our horizontal axis. So our horizontal axis is going to be looking at the acres used for sugar beets. And now we need to put the acres used along the bottom there. So I'm going to start with the number 50, and I'm going to put that at our first little tick here, 50. Then we're going to do 150, 250, 350, and so on. All right, so I put our intervals at the bottom there. And then along the frequency side there, we need to put some numbers. So we need to work up eventually to this 18. So I think counting up by 2s would be a good start. So I'm going to put a 0 at this corner like we always do, and then I'm going to count up by 2s. Okay, so I counted up by 2s on the vertical axis there. And now we have to draw each bar for each interval. So starting off here, between 50 and 150, our frequency is 18. So I'm going to draw this all the way up to 18, go across, and then back down. And you can shade that in. Next, between 150 and 250, we have 6. So that would go up to here. Going to put a bar down like that and shade that in. And remember, these bars are allowed to touch, unlike the bar graph. And I'm going to continue this for the rest of the frequencies. All right, so I finished the histogram over here. So you can see I put in all the frequencies to what we got in this chart up here. There's one thing I want to point out about this graph. You'll notice that this little section of it has a little break in it. And what that means is that the distance or the interval between that 0 point and the 50 isn't the same as the interval for the rest of the graph. So what I mean by that is 0 to 50, well, that's only 50, but the rest of our intervals are 100. And usually when you make a graph, you want to go up by the same interval the whole way, starting from 0. However, they let you bypass that by putting this little break in the graph to show that that interval is not consistent with the rest of the graph. Now, you're only allowed to put that break in the graph at the very start. You can't just put it in over here somewhere, so don't try to do that. So now let's analyze this graph a little bit. What information would you give Quinn's family? The most common area for the sugar beet farms is between blank and blank acres. Well, clearly, the highest frequency, and remember, frequency is the number of farms in this case. So the most amount of farms lie between how many acres? Well, that would be the highest bar we have on the graph up here, which is between 50 and 150 acres. The largest sugar beet farm has an area between blank and blank acres. Well, we have one farm that is in between these 2 acres over here. So that would be between 750 and 850 acres. But only one farm in between those two. That would be a huge farm. The other 5 farms have areas up to the interval from blank acres to blank acres. I'm going to reword this next one here because I don't really like the way it's written. It doesn't really make sense to me. So we're going to say the other farms have areas. Get rid of all this. We're going to say the other farms have areas from the intervals. And we're going to put 150 acres to 550 acres. So what that one was asking there is, we already talked about this farm here as well as all these ones in this frequency, but we kind of ignored all these ones in between there. So the other farms have areas from the interval 150 acres to 550 acres. And I'm going to get rid of this S on the intervals there. And our last question here is my advice to Quinn's family about the number of acres to use for their beet farm. Well, what's the most popular? I would say an example answer here would be 50 to 150 acres. Because that seems to be the most popular, so something must be right about that. But you could have a varying answer here. You could think that that's too small and say 150 to 250 instead.